Okay, so today we'll be looking at slope, and what we need to do is define slope. Now, what is slope? It is the rate of change. And whenever we're talking about the rate of change, we're going to look for the difference, the rate of change. That is looking for the difference between two different numbers. In this case, it's going to be with our x and y. As we already know, x is independent, abbreviating that. And then we have our y. Y, dependent. When we're looking for a rate of change, change means difference between two sets of numbers. Two sets of numbers. And that means we're going to use two different points on a graph and look for the difference, and we'll be able to find slope. Okay, how does slope look like? Slope can look like many different things. Let's just set out our coordinate plane here. X axis, left to right. Y axis, up and down. Don't forget, these are negatives here on our axis plane or coordinate plane. As you already know, positive, positive, negative, positive, negative, negative, and positive, negative. There we go, positive, negative. Got to remember that whenever we're looking at slope here. So slope can look different. There's just about 4 different ways. First, we're going to talk about positive. Not necessarily the coordinates, the dots anywhere on the plane, but we're talking about the slope, which is this right here. But it's over here. Negative, negative, and negative, positive. Slope is a direction of this line right here. Another way you can find slope or identify it is as negative. And with negative, it's moving down. Even if it's over here, this way, it's all pointing down. That is negative. Then we also have 0. This is not going anywhere. This is flat. You can't go up or down. So that means x equals 0. That is what we get as a 0 slope. Up here or down here, it is 0. And here's our last one. Our last one is undefined. This is whenever we have y as equal to 0. And what we're talking about here is just up and down. And so those are the different types of slopes that we can see on a graph. Whenever we're talking about anything, all those positive slopes, positive slope, you'll get a positive answer. Negative slope, you'll get a negative answer. When x equals 0, it'll be literally that. Your slope will equal 0. Slope equals 0. And whenever you get undefined, which is y equals 0, that means you get a funky number. Let's just say 10 into 0. 10 can't go into 0. So that's why we see undefined. That's why we see undefined as y equals 0. Y equals 0 equals undefined. Okay, so whenever we're looking at slope, we already saw what it can be. Positive, negative, 0, or even undefined, up and down. And we have a formula that shows you the difference. Because when we're looking at slope, we already know we want to find the difference between one point here and another point over here. We have it here. 2 and 3. 2, 3. And we have here 8 and 9. We want to find what that slope is. As we can see here, it's positive. It's a positive slope. But what's that number between? There's two ways. We can use a formula between both of them, and then we can check our work by counting, which I'll show you in a minute. So the formula you're going to see first is slope, and we're going to have to look for the first thing here. Like I said, slope is the rate of change. You're looking for the difference between that set of numbers and this set of numbers, which is our dependent over independent, y over x. Got two numbers, you got to find the difference, the change between them. Well, you got to find the change. You ended up over here. That's our second number right here. This is our second. We'll just put number 2 over here. This is our first one, number 1. Our formula is going to be y2 minus y1 x2 minus x1. That is what we're going to go off here. That is our formula we'll be following. We're going to be using our 2 sets of points. We're going to find our x2, remember? Our slope. This is our second one. Here's our y2, 9. Got to find the difference. y1, right here. This is our first one, y3. Over, because we're looking for the rate difference of the change. We got our formula still, x2, 8. The difference, that is x1, which is 2. Here we're going to have to do our maths to find that difference. 3 from 9, you're going to get 6. 2 to 8, 2 from 8, you're going to get 6. Now, when we're looking at this, 6 over 6, that equals 1. Well, 1 into 1. 6 goes into itself one time. So that will mean slope is equal to 1. So we're going to double check that here. We're going to go up here. 1, 1, 1, 1, 1, 1, all the way until we get to our 8 over 9. The easiest way to remember this, rise over run. rise over run. Because remember, we're doing our y's, our independent, or dependent, excuse me, over independent. That's what I'm telling you. Remember your coordinate plane. This is your y, this is your x. X goes left to right. You run. Your rise is going to be your y, up and down. Your rise. This is how you're going to find slope. We can use a formula, y2 minus y1, the difference, the change, rate over x2 minus 1, the difference between the 2 points. That's how we do it if we don't have a graph. But if we do have a graph, we could always rise or run, up, 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 over, 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 1 over 1. You're going to find a point at each point. You'll be able to find it on the line. That's how you know you can find slope. That's how you find slope.